College Algebra Exam 2, or sorry, Exam 3 review over 4.1 through 4.5, 8.1 through 8.3. Going to start with section 4.1. So we want to write the equation in its equivalent exponential form. So this right here is the base. So the 4 is the base. So we would start with a 4. And what power is it? Well, this whole thing right here is the exponent. All right, so that's the exponent. This is the base. All right, so then we would say this is 3y. And the whole thing is equal to this. This is the argument, so that'd be 64. And basically they're saying 4 to the 3 to the what power is equal to 64. Well, I'll show you an easier way to think about this after this, but this is literally true. So if we got these to have the same base, we could actually solve for y. So for instance, 64 is really 4 to the 3rd power, which means 3 must have had a 1 exponent. So basically, the only way this is going to be true is if y is equal to 1. And we can just verify that really easily in here. And this is the easier way to probably look at it is 4 to the 3rd power is equal to 64, because 4 times 4 is equal to 16, times 4 is equal to 64. So again, 4 to the 3rd power, the exponent of just plain old vanilla 3, is 64. So yeah, that means that exponent just is basically going to have to be a 1. Now I didn't really ask you to solve it anyways, but that's how it would look like if you solved it. Now in this case, again, this right here is the base. So we have a base of 3. And what power is it? There's your power right there. It's the 4th power. That's your exponent. And what is it equal to? X minus 1. 3 to the 4th power is 3 times 3 is 9, times 3 is 27, times 3 is 81. So you would say x minus 1 is equal to 81. So plus 1, to undo the subtraction 1 from x. And that would give you 82 is equal to x. All right, so let's try the next one. Write an equation in its equivalent logarithmic form. Okay, so now we're going to flip the paradigm. Okay, so this is going to be a log. And what is the base of this log going to be? Well, the base of this log is going to be the base of the exponent, which is 8. And what is it equal to? What's the argument? The argument's going to be this right here, the 512. And what exponent did it have to be? Well, it was 3. So 8 to the 3rd power is equal to 512. Awesome. Okay, so now we're going to evaluate when we take the natural log of e to the 2nd. Now first I can pull this exponent down to the front, and then that would just give me a 2 natural log of e. Now the base of a natural log is just understood to be an e. So if these are the same, it says, well, e to what power is e? Well, e to the 1st power. So that means this whole thing just is equal to 1. And 2 times 1 is just 2. So we want to write the equation in its equivalent exponential form. Okay. Now I'm going to rewrite this a little bit, do a little bit of algebraic manipulation to get this to be an exponent instead. So I'm going to put it to the top. So that'd be a log base 4, but instead of having 1 over 16, now we're going to have 16 to the negative 1st power over 1, or just we're just going to have a log base 4 of a 16 to the negative 1st power. Or I could put this in front. If I just want to use the exponent instead, I can put the negative 1 in front, like that. And that'd be negative log base 4 to 16. Now, 4 to what is 16? Well, 4 to the 2nd power. So this whole entire thing right here goes to the 2nd power. And then it's negative 1 times 2 is negative 2. Evaluate the expression without using a calculator. So, if this base here and the base of this log are the same, and if you don't see it, it's understood to be a 10 by default, then it's just going to be equal to the argument. In this case, it is 46. Find the domain of the function. Now, the argument, which is what these are, has to be greater than 0. Okay, so in the first case right here, we would have to say this whole entire x plus 4 has to be greater than 0. And over here, this other argument over here, x plus 3, must also be greater than 0. So, we could simply subtract 4 from both of these, and that would give me x is greater than negative 4. Or over here, minus 3, cancel, cancel. We could have x is greater than negative 3. Okay? So, if we put this on a number line and we graphed it, you would see that x has to be greater than negative 4, so it would be this part right here. Right? But it would also have to be greater than negative 3. So what this really means is they both have to be true. Right? The more constrictive the domain. So we would have to be this part. This is the part where they overlap. This part that's greater than the negative 3. So that means if I plug in something greater than negative 3 into either one of these, either this one or this one, it's going to make the argument greater than 0, and that's valid. That's okay. Use the properties of logarithms to expand each logarithmic expression as much as possible. Now, these are actually two different factors. Okay, so one of these factors is z to the third, and one of these factors is z to the second. And whenever you have two factors, or however many factors, then what you can do is you can rewrite those with the same base, but instead you could have them added together. So this would be log base b z to the third plus log base b y to the second. And then next, because these have exponents, you can pull those exponents to the front. And that would give me 3 log base b to the z plus 2 log base b to the y. And over here we were multiplying. That's why they're factors, right? Over here we have a division, so we have a numerator and a denominator. So what we were going to do is we're going to break this up into log base 3 square root of x minus log base 3 27. Now, I can rewrite that square root with a 1/2 exponent, and then I can pull that exponent to the front. So that would give me 1/2 log base 3 of x minus, and 3 to what power is equal to 37, right? 3 to what power is 27? We would say, well, that's 3. So we end up with 1/2 log base 3 of x minus 3. Okay, so the next one, I'm actually going to rewrite this logarithm, base 2. I'm going to put this in parentheses. And then it's going to be x, y to the 4th over 16. And this whole entire thing is to the 1/5 power. So first step on this one is I needed to get rid of that 1/5 exponent. So that would be 1/5 log base 2 x y to the 4th over 16. Okay, so I have the numerator x y to the 4th, and I have the denominator 16. So I'm going to break this apart using addition. So I'm going to say, and that 1/5 is still in front. Now you can either just put 1/5 in front of both of these logs, or you can just leave it outside of the parentheses. So you can distribute it, or you can just leave it outside. So log base 2 x y to the 4th minus log base 2 16. Now that you have this first part broken apart, they are two factors. You have an x times y to the 4th, so this is going to be log base 2x plus log base 2y to the 4th minus log 2 to the 16, or 2 base 2 of 16. Okay, break this up. Now I can pull this exponent, this 4 to the front, so I'll do that. It gives me 1/5. I'm actually going to distribute at the same time. I know I'm combining a couple of steps here, but I'm running out of space. So log base 2 of x plus 1/5 log, and there was a 4 there, so it's going to have to be 4/5 log, because we multiplied by this 4 that we pulled to the front right here. Log base 2 of y minus, And 2 to what power is 16? 2 to the 4th power is 16, but that's going to be multiplied by 1/5, so you end up with -4/5. Okay. Use the properties of logarithms to condense the logarithmic expression. So we're going to do what we did previously, but we're doing in the opposite direction. So right here we see addition, so that means I can convert that instead to multiplication, because both of these logs have the same base. You don't see it, so it's understood or implied to be a 10, but they do have the same base. So you're simply going to be multiplying x by, now you probably want to pull this 7 right here, pull this 7 in front, back up here, and rewrite it as an exponent. So let me break that up a little bit better. So that's log, understood base 10 because you don't see it, but instead of having the 7 in front, I'm going to write it as an exponent. There we go. And now let's combine them with multiplication. So log, don't see it, base 10 understood, x, y to the 7. Okay. I'm going to do the exponents first. So everywhere that you see a coefficient, you're going to turn it into an exponent. So we have 3 in this case that we're going to do that to. So we're going to say natural log of x to the 4th power plus natural log of y to the 7th power minus natural log of z to the 3rd power. Then I'm going to combine the first two because there's addition. Now, if it occurred to you could combine the second two because there's subtraction, that'll actually work. The math looks a little worse, so I'm just going to do it this way, though. So natural log of x to the 4th, y to the 7th, minus natural log of z to the 3rd. Now, because there's subtraction here, I'm going to use that to divide or to write a fraction. So I'm going to use x to the 4th, y to the 7th, and put that over z to the 3rd. Okay, so do the same kind of thing here. So because I have addition here, I can combine the first two. Log x squared minus 1 minus, and what I'm going to do is I'm going to factor that negative out. So there's like a -1 that I factored out here, and that leaves me log. And you don't have to do it exactly this way, but this makes the math look nicer, but it's not necessary. You'll have to deal with kind of a complex fraction if you don't do it this way, though, but that's fine. Now there's an addition there, so I'm going to smush these two together as well. That gives me log 7 times x plus 1. Okay. Except I'm subtracting that whole thing. So okay. So now I've got only 2 logs, same base, but I'm subtracting. So now I'm going to mush them together. Log x squared minus 1 over 7x plus 1. Now at this point you might think you're done, but I can factor that x squared minus 1. And if I do factor that out, that'd give me x times x plus 1 times x minus 1 all over 7x plus 1. And then the x plus 1's cancel out, leaving you log x minus 1 over 7. You do have to do a change of base formula for this. So what you would end up with is log 57.2, and then you would divide that. Let's say you just kept your calculator like a base 10 log, or you could do natural log as well. And then log base 10, most calculators have it, divided by that, and then you plug that into your calculator, which is about 1.46. That's approximately 1.46.